What we're going to do today is we're going to explore soldering as a technique. You need a soldering iron. This is a 30-watt iron here. No, it's 25-watt iron. Sorry. And of course, you'll need some solder and various tools to strip wire with. Importantly, you'll need safety glasses to keep solder from splattering in your eyes. Because what we're going to do, this soldering iron gets very hot and it will heat the solder up and melt it. This is a lead tin solder, and the solder can pop. It can actually pop in your eyes as soon as you have it. So I'm going to put these over my regular glasses to protect the sides. So I look good. So while we're getting ready, we're going to plug this iron up. It usually takes about a minute or so for the iron to get hot. And we'll let that heat up while we're getting our wire ready. This is the wire we're going to solder. We're just going to make a connection here to extend this wire. So this would be like fixing a broken wire. It's just an example. Just take your wire strippers and you just want to cut the plastic jacket off of the metal wire. You want to try not to cut the wire beneath as you do this. And we'll strip that in. And there's a lot of different tools I've got here, what's called a third hand, that can hold your wires for you. But I'm also going to show you a way to do this without using the third hand first. You can actually just use some vice grips and just clamp it like that to hold it up so you can get to it. You want this to hold steady while you're working on it. Now, if you don't have vice grips around, you can just take your pliers and sort of weight it down just to hold it steady for you. One thing you want to be careful about is make sure that you're not soldering around something that'll melt, because this thing, like I said, gets 400 degrees hot, so it'll melt that plastic, it'll melt this wood, the plastic coating on this wood. So you got to be careful where this goes. And this thing is hot all the way over here, all the way from here to there. It's hot and it will boil your flesh. Anybody that's worked with solder irons for a long period of time, eventually they get burned. Just try to avoid it. And I'll make sure it's tight. No, this one's loose. If your soldering iron gets loose on you, the heat won't conduct readily to the tip. Alright. We also have over here, this is my favorite kind of cleaner. There's all different ways of cleaning. Some people use a sponge. I advise not using a wet sponge or a wet towel to clean it with, because it flash cools the tip and causes the tip to wear out prematurely. This is a real good one. It's made out of a brass material that won't melt, and it also has, they put a flux in here to help add flux to the end of the tip. Alright, this is your solder. It's got flux in it. It's embedded in the solder. And flux is a fluid that actually helps clean and helps the solder attach itself to the metals that you're soldering on. So I'm just going to melt a little bit here to show you what it looks like. And so this is our stand, by the way, to hold the solder and keep it from heating everything up. And so we just melt it on the tip like that. You see how my tip is silvered? That's what you want. You want it nice and silvered. And usually just to start, when I first start, I melt some solder on and then I clean that off. And now I know I've got a good surface to work with. Alright, so I'll put this back over here. We're going to use the third hand now. Some people call these a helping hand, some people call it third hand. It's weighted and it's got the alligator clips to help hold your product that you're going to solder on. And so what we're going to do, we're going to solder this tip. We're going to pre-tin it. Remember, we're soldering the two wires together. We're going to pre-tin this wire. That means, since this has tin in it, that's what they call that. I always get my soldering iron wet, so that wet spot will help conduct the heat into the wire. Now I actually want the wire to melt the solder, not the soldering iron, just not blobbing it on there, but actually having the wire. And you can see that it flows into the wire. See how the wire is, it's not just on the wire, it's in the wire. That's a good solder. That's good. That'll make a good connection. Now we're going to do this one. If we solder both ends, there again, we just heat the wire up and let it melt the solder. Not steadiest person in the world, but you don't really have to be. There it goes. Let the solder flow into the wire. Alright. And here's where the helping hand comes in real handy. You can just line these up. I'm going to try to face this where you can see it good. Line these up. And I want this to overlap, like so. Try to get as neat as I can. See, now that's just going to hold in place for me. I'll just add a little more solder here. I think this wire is too big for the heat sink we got, or heat shrink we got. Now you can see that's a really good joint. Overlap like that, and it's in line with the wire, and it's very strong. I don't know, where did that go? Just playing with it. That fell on the floor. Alright, and this is what's called heat shrink. It's a plastic tube, you have to buy it special. And what it does is this stuff shrinks as you heat it up. Hence the name heat shrink. And I don't know if this is going to fit on this wire. I may have to. Alright, I just want a piece of it. I just want enough to cover that joint. Make it nice and neat. Over that. And you can use, you know, that joint's a little big for this. I'll get it on there really good. Alright, see? And then you can use the heat off your soldering iron to shrink it. This takes a long time. Sometimes it takes a while for the heat to get to it. Usually what people do, they'll either have a special gun for it, or I just use a cigarette lighter. And you just want to heat, you don't want to put the flame on it because you don't want to burn it. You just want to heat it up so that it'll shrink on there real good. And you can see it forms to it, and now it won't come off. And that's a good solder joint right there. Okay? So just remember, be aware of the heat off of this. Don't burn your cable. A lot of people have a problem with burning the cable. And certainly don't burn yourself with it. Alright. Now we wanted to show you how to desolder. That's how you solder something together. When you're working with electronics, this is an electronic circuit board. When you're working with electronics, you have to be aware of the components that you're working with. I'll show you the component side. What we're going to do, we're going to remove one of these big fat capacitors. But you've got other little sensitive devices in here, like these diodes and these chips that you wouldn't solder the same way. And usually a technician doesn't remove a chip or something like that. But every now and then you'll find a circuit that has a blown capacitor and you remove it, especially like on a motherboard. In fact, we've got a motherboard over here we'd like to do that too. But I'm just going to remove these big ones because it's a lot easier to see. We're going to introduce you to this tool called a solder sucker or a desoldering tool. And basically it has a little pump inside. I'll just show you that. There's just a little plunger inside here, and it creates a vacuum as it goes back. There's a spring behind it, and when you hit it, the spring right here pulls it back, causes it to create a vacuum and sucks the solder up in there. So the only thing you have to do is make sure that you get the solder heated so that it's a liquid, so that when you hit it with the solder sucker. So I'm going to use this solder gun again. You can see my tip's already starting to get coated, so I need to clean it. And put a little more solder on it. Turning blue. And tin it. Watch my cord. Alright. And then something I usually do, especially if it's a circuit board that's been around for a long time, it'll develop an oxidized layer on it. I will put some solder, extra solder on there before I do the desoldering. You can see the solder turns to a liquid, and then we can just go and suck it away. That's a nice clean desoldering right there. It doesn't always go that cleanly. And then we desolder that in. back in its stand. You should be able to just pull the part out. Check it out. You notice there's a glue on here. Sometimes your parts will be glued into place. But now we can replace this capacitor. While we're at it, let's just give you a little, if I can get this back in here, a little thing about soldering components into a circuit board. Is that going to stay? I don't know. Usually you want to find a way to secure it. I'll use my helping hand to hold it in place here. Let's put that under there. Hold that in place. Up. It wants to move. Because I want that lead sticking up there. When you're soldering on a circuit board, something you have to be concerned with is these little landings where the components go in. Like there's a hole right here. You can actually heat this up too much and cause the copper to separate from the fiberglass. This is a fiberglass board with copper traces on it, and then the copper traces have been, you can see they've been soldered over. But if you heat it up too much, the copper will actually separate from the board. So that's something you have to be careful about. Here I'm just gonna. This is a big area, so it'll handle a lot of heat. And that's what you want, is a good, see how that's flowed around it and attached to the lead? Good. That's the kind of look you want when you're soldering on a circuit board. In this big area, I don't have to worry as much about heat. I can use a lot of heat. But in a smaller area, all right, that's a good connection. So hopefully, if you practice this properly, you'll get good at it. Thank you for your attention.